What's going on, coders? Welcome to this Python 3 video on memory. In this video, we're going to take a look at how Python utilizes memory in order to store our objects and what really happens when we assign an object to a variable. We're going to also take a look at memory referencing and how that is used by Python to clean up memory in the backend. So let's get into it. So let's say that we've got a variable L and we assign the list object 1 through 7 of these integers to that variable. What actually happens? Well, if we imagine the memory stack like I have drawn up here as little boxes, and each box is able to store an object or parts of an object. So let's say that L, or rather the list object that we have here, 1 through 7, is actually stored in the following box, in this little second box that we have from top to bottom, and this box's address is 101. So this list object is now in this box. What happens when we assign the variable L to this list object? Well, you might be thinking, okay, L now stores this object. However, that is not entirely true. What actually happens is that L is now a pointer to the memory address 101. Let's take a look at this in practice. So if we've assigned our variable here with our list object, and then we go ahead and type in ID of L, and ID will essentially give us the memory address of L. So if we run that, we can clearly see that this is the memory address. Now, what would happen if we were to say that LA is equal to L? Well, if we execute that, now LA is the same as L. So if we print it out, print both out, we get the same result. However, if we were to do an ID of LA, then we can clearly see that this is exactly the same memory address as the memory address of L. So essentially, if we were to imagine that we had this line here, which is LA, and that's pointing to L, or that's equal to L. LA is actually not pointing to the address of 102. It's not a different object in memory. It's still the same object. And LA is actually equal to the memory address of what L is pointing to, which is in fact 101. So both LA and L are pointing to the memory address 101, and the memory address 101, this little box of memory here, actually stores our list object. And this brings me very nicely to the next topic that I want to talk about, which is memory and referencing. Now, if we look at these two columns here, we have memory on the left and references on the right. Now, what these are essentially, yes, the memory addresses, and then the amount of references that are currently pointing to each memory address. Now, references are essentially automatically kept by Python, and ultimately what they are a simple counter. So we know that LA and L are both pointing to address 101 in memory. And what that would mean is that we currently have two things or two objects pointing to the memory address 101. So the reference count in here would be 2. If we were to delete LA, if we were to get rid of that, and we were just left with the L object, then the reference count would go down to 1. If we were to say that L is now out of scope and it's no longer being used, then the reference count would go down to 0. And this is where Python would actually know that it can free up this memory address for other uses. Otherwise, essentially, you might get into scenarios where you've got an out-of-memory situation and no one wants to be in that situation. So let us take a look at what this looks like in the code. If we were to say that we have n is equal to 1, 2, and 3, like that, then in order for us to find how many references to this memory address there are, so the memory address of n being 1399930, etc., we can use a function in the sys module. So then we can just go ahead and import sys, and from sys we can do get ref count and pass in n. And then we can get the reference count of that. But as we can see, Python is actually returning 2. So what is going on here? Well, essentially, what happens is that we don't pass n as a value, we pass in n as a reference. So actually, sysGetRefCount is actually giving us what currently is the reference count of n at the time of execution. So actually, because this function is pointing to the memory address that we see here, and n is also pointing to this memory address, actually the reference count is 2. So bear that in mind when you're using sysGetRefCount, because it will always pretty much give you an extra number here on the reference count, which is actually you just passing that memory address to the function. Now there is a C library that you can use to get a more accurate representation of the reference count, but we're not going to go into that in this video. But it is within the C-types library, and you're free to take a look at the C-types library documentation to see what that looks like. So I hope this video has been useful to you and you've actually learned something. Please do post any questions that you might have in the comments down below, and I would be happy to answer them. And I shall see you in the next Deep Explorer video, where we're going to take a look at garbage collection. Thank you for watching. I'll see you in the next one.